Hi. So in today's session, we are going to go over the concepts of forces. So we know whenever where there is an object, and if I want to maybe move it horizontally, or if I want to lift, I have to apply a force. So what does a force do? It moves objects. Not only that, if we are traveling in a car, and if we are going at a velocity or speed of 60 kilometers per hour, and if I have to come to a stop, then I apply the brakes. So what does the brake do? So the brakes stop the wheel from motion, and as a result, the car will come to a stop. So forces do two things. They either make something in motion, or it either makes something in motion come to a stop, or it makes something move when it is at rest. So Isaac Newton was the scientist who was involved in the scientific discoveries of forces and making the theories about the forces. So there are three laws proposed by the Isaac Newtons. So we call that Newton's laws of motion. So there are three laws. So the first law is something that tells what really is a force. So as we just discussed, so if I want to move anything at rest, then I have to apply a force. Or if I have to stop something from motion, then I have to also apply a force. So the first law states that as long as there is no external force, right? As long as there is no external force, something that is at rest will be at rest. So object at rest will be at rest. Meanwhile, the object that is moving with a particular velocity will be moving with the same velocity. So we can say it as how the motion will continue with the same velocity. So remember that velocity is a vector quantity, and since it is a vector quantity, we have to consider the direction. So if something is moving to the right with a particular velocity, it has to move to the right with a particular velocity as long as there is no external force. So we will come to the understanding of what no external force, or we can also say no resultant force, right? We will come to the understanding of what they are, right? In some terminologies, we also say no net force, right? So the second law is, what if there is a force? So the first law is, what if there exists no force? Second law is, what is there is a force? So we know if there is a force, then anything that is at rest will be moving, or anything that is already in motion will be able to either accelerate or decelerate. So that means the velocity is able to go up or come down, right? So that is literally what the second law is all about. So the second law says that if there is a net force acting on an object, right, then that net force is directly proportional to the rate of change in momentum, right? So we know what a momentum is, right? But I will just go over the concept of momentum, but we know what momentum is, and rate of change of momentum, I will tell what that is. So the third one is pretty familiar one. You would have learned or heard about this. Every action has equal and opposite reaction. So it is just the introduction to the Newton's laws of motion. We will go over each and every law in a while, right? Every action has equal and opposite reaction is the Newton's third law, right? So it is pretty much what Newton's laws of motion are, right? So let's talk about the Newton's second law, right? So let's say there is an object of mass m that is moving with a velocity of v. So what is defined as a momentum? So momentum is a physical quantity that tells you the ability of an object to be in a motion. So if an object is having a momentum, so momentum is written as p, and it is the multiplication of mass times the velocity. If it has this much of momentum, then it has the ability to be in the motion with that momentum. So it will be at the in the motion in the same direction since it is a vector. So let's say I am applying a force to this object that is moving with a velocity of u. And we understand that if I apply the force in the same direction as the object is already in motion, then what is going to happen is the velocity is going to increase. So let's say the mass is that, but the velocity has increased or decreased. It could decrease, but in this case, since the force and the velocity are in the same direction, it is going to increase. So it is greater than that of the u, which is initial, right? So I can say that the momentum of the object in the initial state, I'm going to pay pi. I can say it as mu, and I can say pf as mv. So we can find the change in momentum, right? So change of something is always final minus the initial. So it is pf minus the pi. Final is mv minus mu. So that is mv minus u. So that is the change in momentum. So what exactly is the rate of change in momentum? Because we say, or the Newton's second law says that it is directly proportional to the rate of the change in the momentum. So what is rate of change in momentum is the how much of a change has happened over a period of a unit time. So if I say that this is at t equal to 0 and this is t equals to t, then the rate of change of momentum is how much of a change has happened in a unit time. So we have to divide the entire thing by the total time that it has taken for it. So that is what we call the rate of change in momentum, right? Sorry, mv minus u divided by t. So according to the Newton, so the net force, that means this force, is proportional to mv minus u divided by t. It is not equal to v minus u by t. So it is proportional to the v minus u by t. So proportionality means if it increases by 2 times, the right side will increase by 2 times. If the left side goes down by 3 times, the right side has to go down by 3 times. So that is what we call a proportionality. It is not equal. It is the understanding that if one side goes up or down by the same amount over a factor, by the same factor, the right has to go up or down. It doesn't mean that 100 is equals to 100. So it is like if 100 is proportional to 20, and if it goes by 200, it is 40. If it goes 50, it is 10. But no means 100 is equal to 20, right? So we couldn't use this proportionality in day-to-day calculation because it doesn't make sense. I mean, it makes sense in a way, but it doesn't give you the answer like what is the force? You do not know. All you know is, okay, if the rate of change of momentum is twice, the force that you have applied should be or must be twice. But you do not know how much of a force exactly you have to apply. So in that way, this equation is pretty much useless, right? So what the scientists have done after this is they have done few practicals or experiments. So they have made an object move from go from one velocity to another, and they have applied a particular amount of force. You can calculate the velocities at given time or after a while. And doing multiple scientific experiments, they figured that this proportionality itself is the equation. So we call that a proportionality constant. So whenever we do an experiment to figure out a proportionality constant, we have to do experiment. And through the experiment, it was figured that this k is equals to 1. So by the experiment, we have the equation mv minus u divided by t. So that is the equation that we will use most of the time. So in kinematics, we learned that the acceleration is a rate of change of velocity, right? So rate of change, now you understand, rate of change is how much of a change that has happened in a unit time. So it is v minus u by t. So what I can write is, I can write it as ma. So this is the infamous equation F equals to ma, and this is how it is derived, right? So F equals to ma is actually the Newton's second law, right? Any questions? So we will try and understand the Newton's third law, and then we will go into the questions, right? So the third law is saying that whenever there is an action, there is an equal and opposite reaction. But what exactly is that? So let's say I have a mass, right? And we know that there exists a force applied downwards, which we call the force due to the gravity, which is Fg. And we know that this force is exerted on the object. This is the object, right? By the earth. So we are going to use a specific format. So we will say FAB or FA comma B. We will say that this is the force acting on the object A given by the object. So this is a format of FAB, and this is what we will use throughout this force, right? So I can say that this is a force that is given on the object. It is acting on the object. Clearly, it is acting on the object, you can see, right? And who has produced this object, or who is the reason for this force to exist in the first place, is Earth, because gravity is due to the Earth. So this force is there because of the Earth. So we can say this is the object. So let's say object as, oh, it is the force that is acting on the object, and it is given by the Earth. So we call it FOE. So Newton says that if there is a force that is acting on one object as a result of the other object, then there should be equal and opposite force acting on the other object as a result of this force. So we will say this is the Earth, right? And there is a force that is acting on the Earth by this object. So it is given by this object. Okay, so we call it FEO. And this FOE and FEO, we call it Newton's third law pairs, right? And they are equal and they are opposite. So I can say that FOE vector, or I can say the magnitude of FOE is equal to the magnitude of FEO, or I can say FOE vector is equals to negative of FEO vector, right? So there are two ways that you can write this thing. So let's take another example on this. Let's say on a table, I have an object and there is another object, and I'm pushing this object this way, and these objects are moving with the same acceleration, right? So let's say this is mass A, let's say this is mass B, and I'm applying a force on this side. So it is apparent that if I push A, B should move, right? But why the B should move is because A is pushing B. I'm not pushing B because I'm pushing A, right? I'm not the reason for B to move, but A is being pushed by me, but A is pushing B, so B has to move with A as long as A is able to move, or both of these objects are able to move. So let's break these objects separately, or let's draw these objects separately. So that is my object A, and I have another object B, which is kind of small one. So we know now that there will be a force due to the gravity, which is pointing down, which is, I'm going to say FGA, and for the other one, I'm going to call it force due to the gravity on the B. We will come to the calculation of how what is the magnitude of this gravitational acceleration or the force due to the gravitational acceleration and everything. But for the time being, just understand the concept of Newton's third law. So we understand that, okay, if I have these objects, I will have an equal and opposite. Sorry, my bad. I will have equal and opposite force on the earth. So I would have this, and I will have this, right? So I can say this as minus of FGA. I can say this as minus of FGB. So within the brackets, I'm going to use the other notation that I introduced. So this is the force acting on A by the earth. This is force acting on B by the earth. And this is the force acting on earth by the B. And this is the force acting on earth by A, right? So according to Newton's first law, if there is a force or if there is a net force acting in a particular direction, then that object has to move in that particular direction, right? So this object should fall down like this. So they should be moving in the downward direction. But we understand that there is a surface that is preventing it from moving in that direction, right? So what that surface is doing is that surface is pushing that object in the upward direction so that this object is not falling down. So you should understand that surface is providing a force in the upward direction. So understand that I start these arrows from the place where the force is being exerted. So you might ask, okay, why did I draw this arrow at the center? It's because the force due to the gravity acts at the center of mass, and we will assume the center of mass of any uniform objects are going to be in the center of those shapes, right? So that is why this is starting at the center. So why exactly I'm drawing this from the very bottom? Because the surface and these objects are in contact at the very bottom. So that is the point where that force will initiate or exert it, right? So this force is what we call the normal reaction force, right? So we will say Fn, and this is a force that is given on A by the surface underneath it. Similarly, there will be a surface reaction force. So let's call it Fna, and let's call it normal reaction force at B. These are just terminologies or the way that we write it so that we understand which force is which, right? Force acting at B by the surface. So if there is a force, then there should be a equal and opposite force, which is acting on the surface. So we do not have the surface drawn here. So let's draw a surface. So that's the surface underneath that. And we are going to have a force that is acting on that surface. So I'm going to call this the force acting on the surface by the A. Similarly, I will have another one, force acting on the surface at B. And in addition, I am pushing the object A to the right. So I will have this force as well. So there is going to be a force in that direction, right? And there is a force. So remember why the object B is moving is because there is a force given by A on B. So there is going to be a force here. So that force is going to be force acting on B, not A. Force acting on B by A, and in opposite direction, an equal force will act, which is force acting on A by B. So I have drawn with different colors. So those with the same colors are Newton's third law pairs, right? So these two are third law pairs. I don't want to mark it down. If I mark, it will get too clumsy. I made a bit of a mistake here. So I marked these with the same color, but understand those two are not the Newton's third law pair, right? So this one and this one are Newton's third law pairs. Oh my God. Sorry. And this one and this one are third law pairs, right? Other than that, it is basically color coded. Yeah. Yeah. Yeah, it is. So we have something called a free body diagram, right? I don't know whether you would have heard that term. free body diagram. So in exams, if you're asked to draw the free body diagram of an object, so what does a free body diagram give? So it gives you the understanding of all the forces acting on a particular object. So it is all the forces acting on an object, right? So if I ask you to draw the free body diagram for the A, then we have to only draw the forces that are acting on A. So we do not need to worry about this. We do not to worry about this. But anything other than those, we should draw. So all these forces will be there in a free body diagram for the A, right? So that is your free body diagram for it. Similarly, for B, we have to include this, and this. So that is your free body diagram for B. Okay. So free body diagram should have all the forces acting on that particular object, right? So if I ask you to draw it for A, you have to only draw it for A. You don't need to draw it for the B. Okay. Any questions up until this point?